So the distribution of arrival times for fire trucks arriving on a scene is uniform with a minimum value of 2 minutes and a maximum value of 15 minutes after being called. So if we were to graph this, you can see that the lowest value, A, would be 2, and the highest value would be 15, and the height of this rectangle would be 1 over B minus A, which would be 1 over 13. Okay. So let's try and calculate the following then. Let's say we're trying to find the probability that a fire truck will reach the scene within 7 to 10 minutes. Okay. So we can just do a quick sketch down here. Here is our distribution. It starts at 2 and it goes to 15. And what we are looking for is the probability in between 7 and 10. So we'll be looking for this area. So we can just write the probability nicely. It's the probability that x goes in between 7 and 10. That has to be equal to the base times the height. The base will be given as in between 7 and 10, so 10 minus 7. And the height is given as the probability density function. The height is 1 over 13. And then we just do a little calculation. So 10 minus 7 is 3. We multiply that by 1/13. So the probability that x goes in between 7 and 10 minutes is 3 over 13. Now let's calculate the probability that the fire truck will reach the fire in less than 6.5 minutes. So again, it's just nice to draw a little picture to give yourself a reference. Here's our uniform distribution, starts at 2, goes to 15, and now we are looking for less than 6.5. So we are trying to calculate this area. So the probability that x is less than 6.5, again, we're looking for the base. We'll multiply that by the height. The base goes in between 6.5 and 2, so we'll take 6.5 and subtract 2. And multiply by the height of that rectangle, which is 1 over 13. Doing simplification, that's 4.5 times 1 over 13. And when we put this in, let's see, so that is 4.5 over 13, and that is approximately 0.3462. So there's about a 34.5% probability, or there's a 0.3462 probability that the fire truck will get there in less than 6.5 minutes, or about 34.5% of the time. Okay. So let's do the next one. What is the probability that the fire truck is going to take longer than 12 minutes? So again, our distribution goes in between 2 and 5. We are looking for the probability of 12 minutes and being greater than that. We would write that as the probability that x is greater than 12. Again, we're just calculating the base times the height, just the area of that rectangle. Now the base is in between 12 and 15, so the base goes 15 minus 12. Multiply it by the height, 1 over 13. And again, what we will get is 3 over 13. Now we can also ask about the quartiles. So the first quartile, remember this is the value below which 25% of the data falls. Okay, so if we were to draw that, what we would be looking for, again, between 2 and 15, we are going to be looking for 25% of the data. So we'll be looking for an area that has 25%, and we're going to be looking for that value k. So the probability is just the area. We know the area is equal to base times the height. We want the area, because we're looking for quartile 1, to be 25%, but remember to switch that into a decimal. The base now goes in between 2 and k, so the base is k minus 2, and the height stays the same. It is 1 over 13. So this is what we have to solve this equation for k. All right, so let's multiply by 13 on both sides to cancel. And when we do that, we get 3.25 must be equal to k minus 2. And when we add k to both sides, when we add 2 to both sides, we see that k is equal to 5.25. So 25% of the time, it will take fire trucks 5.25 minutes, or 5.25 minutes to arrive on scene. Now, a quartile really is just a percentile, and this one they're asking for the 60th percentile. So we're looking for the value at which 60% of the data falls in between. Okay, so now we're looking for some value k, and the area that we're looking for is 60, and we just do the same thing that we did before and just change the value of the area. So area is equal to base times height. We are looking for the 60th percentile, so we're looking for area to be 0.6. The base goes in between k and 2, so k minus 2 is the base. Again, the height has not changed. This is 1 over 13. And just doing some algebra now to solve for k, multiply both sides by 13. So we will get 7.8 is equal to k minus 2. And adding 2 to both sides, then we see that k must be equal to 9.8. So 60% of the time, the fire trucks will arrive there in less than 9.8 minutes.